Hi everybody. I just wanted to give you a brief rundown on geometric series. These things are important for our queuing theory discussions because we make use of them during our proofs and during some of the results that come from the queuing of individual packets as a geometric series. And so what we do here is we start off with a simple summation. And rather than using sigma, I'll just use big S sub n to show that we're summing the first n terms in the geometric series. And so when we look at the addition of a series of numbers with a common ratio r and a common coefficient a sub 1, we wonder, well, what happens if we multiply by r? And which of the following do you think is correct? And take a moment and take a look. And let's take a look. If the answer is B, if your answer was B, you are correct. Multiplying by R will give us A1R. And now what we're going to do is go to our next question. Suppose we had these two geometric series and we wanted to do a subtraction. Then what would we have? And you can see there are many common terms there. What's the value of the subtraction of the geometric series? And if you take a look, think about it for a second. And then if you thought the answer was B, you're correct. What we want to do is we want to subtract the tandem geometric series terms, and then we're left with A1 minus A1 times r to the n. And naturally enough, next question and part of the derivation, if we want to isolate s sub n and say s sub n is equal to something, what would it be equal to? And you can look through the results, and if you thought the answer was A, you were correct. And that gives us a derivation of the sum of the geometric series, and all the rest is meant to show us applications. And so once we have that, suppose we let the first 10 terms add with a common ratio of 1. Well, now what do we get? And take a look. And if you thought that the answer might be C, you were correct. We're adding 10 times. You can't use r equals 1 in the denominator for obvious reasons. That gives us a 0 in the denominator. So instead what we're doing is we're taking 10 and adding it 9 times to get 90. And so there's an exception. You have to make sure r is not equal to 1. Otherwise this formula simply doesn't work. Let's try another application. Suppose now we have the following geometric series. What do you suppose it's going to do relative to 2 to the n? Is it always going to be less than or equal to or greater than? Think about it for a moment. If you thought the answer was C, less than, then you were correct. If you just write it out, that may be helpful. You can see that it's always going to be less than 2 to the n by, well, at least 1. Well, always by 1. Here's another example, and this is typical for interest rates. We have this person who's apparently working for $10,000 a year for a period between 2008 and 2020, which is 12 years. What will n be? Once you know that, you can quickly identify a couple of selections, but then the question becomes, what should r be? He's increasing his salary by 5%. Should r be 0.05, or should it be 1.05? Or should we be using 13? What do you think? And if you thought the answer was D, where we use 1.05, and we use 12 times for the number of years where they get he gets paid, You are correct. and that gives you a number which you can plug in. And that's my introduction to geometric series. So bottom line on this, you want to know that it's a1 minus a1 r to the n, where r is the ratio of the increase, divided by 1 minus r. Thank you.